All right, today we're going to talk about our parallel lines, proportional parts, and similarity. So first let's get into the triangle proportionality theorem. And that says if a line is parallel to one side of a triangle and intersects the other two points, then it separates these segments into proportional sides. It's also called the side splitter theorem because you're splitting one of the sides. So this is going to be proportional to that. This is going to be proportional to that. And you can set it up different ways, but that's the proportional way to do it. All right, so it's pretty easy. We're just looking for parallel lines. And once we've got that, I know this and this are parallel, and this and this are going to be parallel. So let's go ahead and get started with the first example. And I did some of the labeling for you already. So here it says JK equals 7. So JK is right here. I know KH is 21. JL is 6. We're looking for LI. So this is the part that we're missing. Well, if you notice, your parallel lines are right here. So that means that 6 and X are going to form one proportion. And since I started with this side, I have to start with this side. And now I'm going to go this to that and set it up here. And then again, cross multiply, and you'll get 7x equals 126. X is 18. So now we know that x is 18, which is Li. So it's pretty easy as long as you understand what to do, but you're looking for the parallel lines, and then whatever splits it, then those, of course, the sides on there are proportional to each other. All right, so number 2, you're going to go through, you're going to label all the parts. Now TV is right here, and that's x minus 1. That's okay, you're still setting up a proportion. VS is 17.5, so you need to find X and TV. So your parallel lines are here, so I know this side and this side you can set up over this side and this side. So you can go SU over UR and make it SV over VT. So go ahead, you're going to solve this one. I got it partially set up for you. And then now let's look at this one. This one is a little tricky because you actually have two triangles. You have a triangle here and, you have a triangle here. So you could do that, or you could draw two little triangles if it helps you, but the side splitter either works. So the side splitter theorem, here's your parallel lines. So I know this section and this section make a proportion, which would be here. And I know this section and this section would also make a proportion. So if you notice here, it only gave you the total length. So to get this part right here, I took the total minus 5x, and I put that there. So again, you're going to set up a proportion with this side and this side. And you're going to have it, since we started with this one, I have to start with this one. Or excuse me, with this one, because that's the 16 that goes with it, right? 36 minus 20. So I'm going to go 16 over 20, which is your proportion here. Cross multiply, but remember, this is in parentheses, so the 20 is going to everything. And you'll get that, solve for x, x equals 5. That's one way to do it. Another way to do it is what I did down here, a little bit easier, but it's not really the side splitter proportion. I just set up two triangles and made a proportion that way. So you could do this way, but this is not the side splitter. But either way works to solve this. So on this one, you have your parallel lines here. So we can figure this one out to be 20. And then I know, since my parallel lines are here, I know this side and this side are going to be a proportion. And then I know this side and this side are going to be a proportion. And you equal them to each other, cross, multiply, and solve. All right, the converse of triangle proportionality theorem says that if you have a proportion here and here, and it equals that, so your proportion is this over this, and it equals that over that, then that means these lines must be parallel. So you're basically just checking if the proportionality theorem works, then you know these lines are parallel. So let's go ahead here, and we're going to determine whether it's BC is parallel to DE. And then it says for the third, find X and Y. So let's look here, let's label our parts AD, DB, AE, and EC. So again, we want to know, are those parallel? So if they are parallel, then we can set up a proportion. So I'm going this side to make this proportion. I'm going to equal it to this side over this side. You can do your cross multiplying or simplifying, and we know that we got 120 equals 120. So yes, BC is parallel to DE. So we know those are indeed parallel. All right, so let's check this one. Again, label your parts. So BD is 9, which is this guy. BA, which is the total length here, is 27. So then you have to figure out what this little part is. So you just subtract them. And then CE is 1/3. This one's a hard one. Or is that CE? CE is 1/3 of EA. So if CE is 1/3 of this, you actually need 3 of these guys to get 1 EA. So you could think of it either way here, but you could either make this 1/3 EA, but I think you need 3 of these to equal 1 of those. All right, now that you got that set up, and don't forget, you can, this is 18 here. So now we can determine, we can figure out, are these parallel? So set up, we've got 18 over 9, and then we got 3x over x. Cross multiply, and then 18x does not equal 27x. So since it does not equal, they are not parallel. All right, I want you to try this one. And again, think of what sides are proportional. So we want to know if these are parallel. Well, you can still use this as proportional. So we're looking here to see if they're parallel, but you can go this over here, this. And we want to know if that is, you have to, I would solve for y first. Once you get y, then you can figure out the sides and solve for x. So I got you started. So we have to figure out what y is first. Then once you get y, plug it in here. Then you can start to make your proportions with this side. So you're going to finish that part. And then we'll go over it later. But solve for y first. And go from there. All right, you have 3 parallel line theorems. This is basically the same thing, but in this case, you just have 3 or more parallel lines, but it's still proportional, so they cut off every segment on the transverse, so the transversal. The corollary is just that if they intersect 2 transversals, then they cut off the transversals proportionally. So really, it's just saying this guy to this guy, because we have 3. So all of these sides would be proportional, and all of this side would be proportional. All right. So I did this first one here for you. So if you notice, we've got 1, 2, 3 parallel lines, and we've got our 2 transversals. So that means if this side is congruent to that side, then we can mark here and here as congruent. So now we can go ahead, I would actually solve for x first by equaling, because this is congruent to that. Once you get x, x is 6. Now we figured that out, so we can do the same thing over here to solve for y. Now to get rid of the denominator, you're going to multiply by 3 and multiply everything on this side by 3. And you'll get 8y plus 21 equals 15y. And then simplify and you get 3 equals y. So that's all you had to do. Now for this one, here's your hint, is you have these 3. And it's proportional. And nothing's marked equivalent. So if you know this is 77, so you have to figure out what is this part. So what I would do is go through, set up a proportion. This over this equals, and you could make this 77 minus x if you want, and then set up a proportion that way. All right, lastly, you have an angle bisector theorem. We've talked about angle bisectors, how it splits one big angle into 2 smaller congruent angles. But now we know an angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other 2 sides. So this is your angle bisector here. So I know this over this, A over C, is going to equal B over D. So it split this triangle there, A over C is equal to B over D. So let's look here. Here's our angle bisector. That's split. So I know one side of the triangle is going to be equal to the other side of the triangle, which is here. And then again, cross multiply, solve for x. So again, look for your angle bisector, which is here. And I know this is going to equal that over that. So go ahead when you're solving this, set up your proportion, and that is your angle bisector theorem. So remember, parallel lines, proportional parts, so you can do the side splitter theorem, which says the proportionality, if you have parallel lines, this is going to be proportional to that, and that's going to be over that, so they're going to be proportional this side to that side. And then the 3 parallel lines, so they cut off congruent segments on every transversal. So here we just talked about it, and then you can solve that one. And then angle bisector theme, it cuts off one side of the triangle and it makes that proportional to the other side of the triangle. And that is your parallel line, proportional parts, and similarity.